Hello everyone. In this video, we will be discussing some of the numericals on wire ropes. So already in the previous videos, we have discussed about the design procedure, what is a wire rope, the concept, all those things we have discussed. Do go through those video, then only it will be easy for you to understand. Because here once again, I'm not discussing any design procedure. Directly, I'll be discussing the problems. So three problems we'll be discussing, and all the three problems was taken from VTU prescribed textbook, that is Design of Machine Elements, and the author is VK Bandhari. So from that textbook only I have chosen all these problems, and all these three problems what we'll be discussing right now, which is very important in the university examination point of view, because from the previous year question papers only I have chosen these questions. So please pay your attention and try to understand this one. So let us move to the question given. So select a wire rope to lift a load of 10 kilonewton through a height of 600 meter from a mine. The weight of the bucket is 2.5 kilonewton. The load should attain a maximum speed of 50 meter per minute in 2 seconds. So here they have not mentioned the type of the rope. So whenever it is not mentioned, always we can assume the type of the rope is 6 cross 90. That is 6 strands, and each strand consists of 19 wires. So that is the meaning. And the same table for the 6 cross 19, I'll be writing the ultimate load, which is equal to 500.8 d square n, and where d will be in mm, and the weight per meter length is equal to 36.3 into 10 power minus 3 d square newton per meter, where again the d will be in mm. So these data is available from the design data handbook table, and other data would be the wire diameter dw equal to 0.063 d, and area of cross section A equal to 0.38 d square, and sheave diameter capital D equal to 45 d, and from the table factor of safety n is equal to 7. So starting with my assumption 6 cross 19 as a wire rope, I have taken all these data from the table and 19.7. So from 19.7 all these values we can able to take it. So we'll move to the solution. As we discussed in the design procedure itself, all the formulas are note, so we need to remember that. So first formula is nothing but total weight of the rope. So it is denoted as WR, which is nothing but weight per meter length into length of the rope. So 36.3 into 10 power minus 3 d square, that is nothing but weight, and length is 600. So we will be getting WR as 21.78 d square, and inertial load due to acceleration WI, which is equal to ma. So W plus WR by G into A, where acceleration is not given, so I will be using the equation V is equal to U plus 80. Since U is 0, that is initial velocity is 0, so V is equal to 80. So where I know that V value and T value, so 50 by 60 into 2. So 50 by 60 is nothing but the velocity, and T is nothing but time. So the acceleration is 0.417 meter per second square. So a WI value I will be getting after substituting in the formula. It is 531.345 plus the 0.9258 d square. And moving to the next step, bending load. From the data handbook we can take it down, that is the equation 21.63, where the formula is PV equal to K into A into dW by D. So K is a value which is present in the data handbook itself, that is 8278.5 Newton per mm square. Substituting all these value and dW and D in terms of small d, so we'll be getting the bending load PV as 44.01 d square. And the next step is nothing but starting load, which is denoted as WS. The formula is 2 into W plus WR. So both W and WR is known. After substituting, I'll be getting WS value as 25,000 plus 43.56 d square. So the maximum load, assuming the impact load is neglected, the formula F max is equal to W plus WR plus WI plus PV. So all the values are known. So after substituting in this, I'll be getting F max as 13031.345 plus 66.7158 d square. And finally, diameter of the rope, the formula is FA, allowable load, which is greater than equal to F max. So which is nothing but ultimate load divided by factor of safety, which is greater than equal to F max. So I know FU value, it is 500.8 d square from the table I have chosen. Similarly, factor of safety value also I know, which I have taken from the table, which is equal to F max value, that is 13031.345 plus 66.7158 d square. So after simplifying, I'll be getting a d value as 51.96. From table 21.40 for 6 cross 19 row, the standard diameter would be 54 mm. Then we shall move to the next problem. So select a wire rope for a vertical mine hoisting to lift 12,000 kilonewton of ore in 8 hours. Shift from a depth of 720 meter. Assume two compartment skip with the hoisting skip in balance. The maximum velocity of the rope is 750 meter per minute with an acceleration and a deceleration periods of 12 seconds. So the rest period for the load and unload is 10 seconds. The hoisting skip weighs approximately 50% of the load capacity. So here the load, total load to be lifted in 8 hours would be 12,000 kilonewton. So convert that into Newton. So 12,000 to 10 power 3, and available time is 8 hours. Convert that into seconds. So 28800 will be the available time, and the compartment is 2 compartment skip. So here the load is available in each travel. So the velocity V equal to 750 meter per minute converted into meter per second. That means minute to second is 60. And the depth h is given as 720 meter, and the period of acceleration d is 12 seconds, and period of deceleration is 12. So both acceleration and deceleration is there, so we should focus a little more. The load and the unload time is 10 seconds, and the weight of skip is 0.5 times of load capacity. First, from the table 21.48, when the depth is 720 meter, we can take down the factor of safety value. It is 6. So the time required for each trip is acceleration time plus constant velocity movement time plus deceleration time plus load and unload time. We know all the values, but we do not know what is A. So first let me find out the A value with the help of V is equal to U plus AT, where the initial velocity is 0. I know the velocity and the time. After substituting, I am getting velocity, acceleration is 1.0417. And by using one more equation, let me find out what is the SA equation. So this V square is equal to U square plus 2AS, where SA value I am getting as approximately 75 meter. So this is the distance moved during the period of deceleration. So remaining distance will be moved by the constant velocity SC, which is nothing but 720 minus SA minus SD. So the value would be 570 meter. So here the time required to cover this distance with constant velocity TC is nothing but SC by V, which is equal to 570 by 12.5, that is 45.6 seconds. And the total time taken for each trip T equal to TA plus TC plus TD plus TI, which is equal to 79.6 seconds. And the total number of possible trips in 8 hours is 8 into 60 into 60 divided by 79.6. So it is totally 362 trips. And the load on each trip can be calculated by the formula total load divided by number of trips. So that is 33149.2 Newton, approximately 33150 Newton. And the weight of the skip is 0.5 into load capacity. So 0.5 into 33150, it is 16575 Newton. And since the commonly used rope is 6 cross 19, so from the table I'll be getting in the previous problem also we discussed. So FU value and weight per meter length, wire diameter and sheave diameter, all the values I have taken. So let me start the problem with the value, with the formula. First step is total load. So load to be lifted per trip plus weight of skip. So I know the value. So 49,725 Newton is the value, and total weight of the rope, weight per meter length and length of the rope. I'm getting the WR in terms of small d, that is wire diameter. The value is 26.136 d square. And the third step is inertial load due to acceleration. I know the acceleration value, that is 1.0417, and both W and WR value I know. After substituting, I am getting the value is 5280.18 plus 2.7753 d square. Then the next step is bending load. This is very similar to the previous problem what we discussed, except the first portions, that is the acceleration deceleration time. So bending load, if you substitute, means I'll be getting PB in terms of d square, that is 44.011 d square, and starting load W is equal to 2 times of W plus WR. So the value is 99450 plus 52.272 d square. So the maximum load, I'll be going with everything, and finally neglecting impact, I'll be considering the values 55005.18 plus 72.922 d square. So the diameter of the rope, that is allowable factor, allowable load, which is greater than or equal to F max. So from this FU and factor of safety formula, I am getting the D value as 73 mm. From the standard diameter table, I will be rounding. Thank you.